Alright guys, looking at these examples, notice how first we're going to get the structure. So here, when I see f of x, it's going to be in its own parentheses, being squared. Remember that an exponent is just a list of repeated multiplication, so this is just saying I have two of these. So when I see this in a problem, it just means I have two of these. So I have f of x times f of x. That's all it means. And then when we multiply, guys, remember that multiplying is nice because everything multiplies, and when we do this, the exponents will change. So in this example, what is f of x? So f of x in this table is going to be defined as x plus 8. So let's go and write that down twice. So it's x plus 8 times x plus 8. Now from our previous notes, this is a binomial times a binomial. So it's a 2-term by a 2-term. And if we use the box approach here, I'll make a 2 by 2 box. And guys, hold on. Let me draw the box here on this side, just because I made kind of a mess there. So it's a 2 by 2 box. So x plus 8, I'm going to put here along this side. X will take this row, and then plus 8 will take this row. And then another x plus 8, I'm going to run it along the top. So x and then plus 8. So this will give me a very organized way to do my multiplication, keeping my work very clean. So to fill in this box, the question is, what is x times x? So as a list, I have two x's, so x times x is x squared. So I'll put that in black here. To fill in this blank box, the question is, what is 8 times x? And when you multiply a number and letter, just stick them together. So 8 times x is 8x. To find this empty box, it's 8 times x again, so it's another 8x. Then to finish, to fill in this box, the question is, what is 8 times 8? And that's 64. Now, once you finish filling in the box, we're done multiplying. Your last step here will then be to see if you have any like terms. And it'll be common for us to find like terms here in diagonals. So here, 8x and 8x are like terms. So I can combine those. 8x plus 8x is simply 16x. Remember that when we add like terms, the exponents do not change. So that's why this stays as an x. And then to finish, I have an x squared, which is out here in front, and a plus 64, which is out here in back. So this is the answer to example E. Guys, again, I kind of spell off the page here, so sorry about that, but that's how that one works. Now I'll show you one more example here in this video, but do take note here that in this example, when I multiply the same function together, I end up having some common terms here. So kind of keep that in mind as we move along. Example G, m of x times m of x. So just to be clear, because I have two of these, I could also write this as m of x quantity squared. So I can kind of go in reverse to example E. There's no need to, but just know these are the same thing. So in this case, m of x is x minus 8. So I'm going to have x minus 8 times x minus 8. Again, this is a 2 by 2 term problem, so I'll make a 2 by 2 box. I'll put x minus 8 here on the side, then x minus 8 here over the top, and I'll multiply. To fill in this first box, it's x times x, that's x squared. To fill in this box, it's negative 8 times x, that's negative 8x. Again, just stick the number and the letter together. Down here in this empty box, negative 8 times x, again is negative 8x. And then to finish this multiplication, this will be negative 8 times negative 8, that's going to be a positive 64. So plus 64. So again, once the box is complete, you're done multiplying, but you do want to scan for like terms, and again, in this case, in the diagonals, I have like terms. So I can gather those up a little bit more, and I get negative 16x, because minus 8x minus 8x is minus 16x. And then I finish here with an x squared up in front, and a plus 64 here to the back. At this point, I'm stuck, so I can't do any more combining. So this would be the answer, the result of multiplying x minus 8 times x minus 8.